Now that we have an understanding of what a three-dimensional shape looks like and how it's built, we can find the lateral area and surface area of prisms and cylinders. That's what our focus is today. And there are equations that you can do this, but you can always go back to what we learned about a net. So first, let's talk about the difference between lateral and surface area. So your bases, let's look at these pictures here. So if you have your bases, these right here. So that's the base of your pyramid, because this will apply to everything, even though we're not going to talk about pyramids. And then we've got your cylinder, that's the base, and then you've got your circle down here. That's the base of your cylinder. So you have lateral faces and then you have bases. So the lateral area is the area of all of the surfaces except for the base. Okay, so in the pyramid, the lateral area would be the 4 triangles. And then the surface area is the area of all of the surfaces. For the cylinder, it would be the area of this, like the green bean can wrapper. That would be your lateral area, and then your surface area would include your 2 bases. So we have 2 formulas that we're going to use for prisms. So our lateral area of a prism is our perimeter of our base times the height. Now, the height is the distance between the 2 bases. It's not necessarily how tall it stands vertically, because remember that your bases are not always going to be sitting on the ground. Okay, so the height is the distance between the bases. Now, what the perimeter does is basically, like if you look at number 1, I could find the lateral area. Now, we have some flexibility here. We can use whatever base we want because we have 3 sets of both that are congruent and parallel. So I like to use the one that it's sitting on just because that's handy. And so if we look at that, well, the area of the front face would be 10 times 4. And then the perimeter of the right face would be 10 times 4. And the back face would be 10 times 4. And then the left face would be 10 times 4. Well, notice that it was always 4, right? It's always the 4. I could just shortcut that, find the perimeter of the base, and multiply it by 10. That's where the formula comes from. And then we have our surface area. Okay, our surface area is everything else. Okay, so the lateral area is the area of the lateral faces. That's everything but the base. So our surface area is our lateral area plus the area of the 2 bases. Okay, so P stands for the perimeter of the base, H stands for the distance between the 2 bases, and B, capital B, stands for the area of the base. Now for a prism, that's going to depend on what shape the base ends up being, so we'll have to go back to those formulas that we used in the last chapter. Okay, so if we do lateral area is pH. So I like to find my perimeter, the area of my base, and my height. I like to write those down. So the perimeter of the base, I like to highlight the base too. So the perimeter of the base would be 4 plus 4 plus 4 plus 4. I need to get my calculator here. That's 16. I should be able to do that. The area of the base is a square, even though it doesn't look like a square. Remember, that's drawn 3-dimensional, but it is the square. The area of a square is base times height, 4 times 4, so it is also 16. That's coincidental. They're not always going to be that way. And then H is the distance between the 2 bases. So the distance between the 2 bases, pick a vertex and connect them. That's your H, okay? So my H is 10. Now I have everything I need to use the formulas. So I do the perimeter, which was 16, times the height, which is the distance between the 2 bases, which is 10. So my lateral area is 160 feet squared. Now my surface area, what I want to do is add the 2 bases. Okay, so let's be clear. My lateral area is all this green part. Okay, now I know it's covering up the bottom, but it's all of that green part, okay? It's the sides of it. And then the bases are going to be, my bases are going to be the top and the bottom. Okay, so then I'm going to take my original, what I just found for my lateral area, and I'm going to add 2 bases. Well, I found that my bases had an area of 16. So I would take 160 and add 32 and get 192. So surface area would be 192 feet squared. If you've ever looked at a roll of wrapping paper to decide if you have enough, it's sold in square inches or square yard or square feet. And so this is how you can decide whether you're going to have enough wrapping paper or not. You can calculate the surface area of your gift that you're going to wrap. Now for number 2, this is a triangular prism. I'm going to find my bases. I always like to bring out my bases so that I know what I'm using. Okay, so we have that our bases, this is a 3 by 3 triangle, and we know that here's the other base. So I need to, in order to use the formula, we go look up the formula, right? And so the formula is perimeter times height, and then perimeter times height plus 2b. Those are the formulas that we need. That means I need the perimeter. I need the perimeter of the base. Well, it says round your answers to the nearest whole number, right? So that'll be easy enough. So I need to use Pythagorean theorem so that I can find the perimeter of the base. So I take a break for a second, come over here, 3 squared plus 3 squared. And since it says that we can round, I can do 9 plus 9 and get the square root of 18. And so this side is 4.2. So I'll round it at the very end, but right now my perimeter is 3 plus 4.2. So my perimeter is 10.2. Okay, the height, that's the distance between the two bases. So that's pick a corner, corner to corner, vertex to vertex. So my height is 10. And then I need the area of the base. Well, the base is a triangle. Okay, now remember base times height divided by 2. Your base and your height of your triangle have to be perpendicular, and the 3 and the 3 are perpendicular. So it would be 3 times 3 divided by 2, which is 4.5. That would be the area of the triangle. Now we have everything we need to do our formulas. So the perimeter is 10.2 times the height, which is 10. So 10 times 10.2 is 102. So my lateral area, which is all of my rectangles, my 3 rectangles. Now I could have done 10 times 4.2, 10 times 3, and 10 times 3 and added those together, and I would have gotten the same thing, 102 inches squared. And then my surface area is going to take that 102 that I just found and add the 2 bases. So I'm going to add the 9 back in, so I get 111 inches squared. Okay, so every time, use those same formulas every time. And the only thing that's going to change is the B, the area of the base. Okay, so again, we need pH and we need pH plus 2B. So notice this time that I have hexagonal bases. Okay, it's obviously not drawn to scale if the hexagon has a diameter of 16 and then the height is 3. Okay, so I do want to draw this out a little bit bigger to take it back because now we do have to find the area of the base. This is our base, right? And it has this diameter of 16 that passes through. Remember, we have a radius. That means we also have a diameter. So if that's 16, this is 8. Now, okay, let's take a break from the 3-dimensional. Let's go back to our 2-dimensional shape. This is a hexagon. That's the apothem times the perimeter over 2. So right now, I'm just looking at the hexagon, nothing else. So I need to find the apothem. Okay, so I'm going to draw in that apothem. Remember that we found those central angles. All of these are 60, which means this is 30. Okay, so now we've got our 30, 60, 90 triangle. So I know that this is 4, because if this is 2x, then the 4 is my x. And then my apothem is 4 root 3. That's my x root 3 side. So I have 4 root 3 and then times the perimeter. Well, the perimeter, remember, if the radius is 8, then all of my side lengths are 8. So my perimeter is 48, which we're going to need that in a minute anyway. Okay, so perimeter is 48. And then over 2. So we'll find this. So 48 times the square root of 3, or 4. So we got, 4 times the square root of 3. So we're just going to get our decimals. So 48 times 4 times the square root of 3 divided by 2. I get 166.3. 166.3. We could have left that exact, but since it said to round to the nearest whole number, we'll go with that. So that's my B. And then my H, so I've got my P, I've got my B, I need my H. That's the distance between the two bases. So pick a vertex and find that. So then my H is 3. So my P was 48. My height is 3. So the area of all 6 of those rectangles is 48 times 3, which is 144. And that's centimeters squared. The surface area, take that 144 that you just found, that means you got to trust what you're doing, and add 2 bases. So I'm going to add 2 of those hexagons. So I have 144 plus 2 times 166.3. And that's 476.6 or 477 centimeters squared. Okay? So you can try these next 3. Again, if you do your lateral area, this is a cube, so this is actually easier almost to think about. Find the area of one of them, or the perimeter of the base, right? If you do your perimeter, so you have 7 times 4, that would be 28, times the height, the distance between them, that's 7. So 28 times 7 is 196. You could also do 4 squares at 49 apiece, 49 meters squared apiece, so that's meters squared. Then you've got your surface area, add 2 more squares, so take the 196 and add 2 more squares at 49. So 196 plus 98 is 294 meters squared. Okay, now with 5, I'm just going to talk you through this. You can go through and do the math, but you need the area of the base first, right? We need the perimeter of the base and the area of the base. Well, the base is the trapezoid because what we're looking for is parallel and congruent. We've got those rectangles are parallel, but they're not congruent. So we've got this as 8.1. So then it's easy enough. We've also got our height. Be sure you look around at your shape, see if you have anything. So to find your base, you would use the area of the trapezoid, right? Half of base 1 plus base 2 times the height over 2, or half. I said half, so just do half. Half times 8.1 plus 2.8 times 3. And then that would give you the area of the base. And let me go ahead and try. Let me show you this. So we've got our perimeter. Our perimeter would be 4 plus 4 plus 2.8 plus 8.1, because it gets a little confusing. So we have 18.9. Now I need the area of the base. All right, that's half. Now all you're going to look at, just totally ignore the rest of the shape except for that green trapezoid. Base 1 plus base 2 times the height of the trapezoid, which is 3. Okay, so we're just trying to find the area of the trapezoid. We're not trying to find anything else. So 8 plus 1 plus 2.8 times 3 divided by 2, you get 16.35. So that's the area of my base. And then I need my height. Now, this is the height. This is the distance between the bases, okay, because now I need to go that direction. So that is 12. Okay, you have to be careful here. That height is not this height. The height of the trapezoid is not the height of the shape. Okay, so you have to be careful with that. So you can find the lateral area and the surface area from that. For 6, we've got our bases. Again, it's not sitting on its base. We need them to be congruent and we need them to be parallel to each other. So we have those 2 triangles. So I've got my distance between my 2 bases. So there's my H. I've got my perimeter. I can find that 10 plus 10 plus 6. So my perimeter is 26. Now I need my big B, my area of the base. So totally ignore the rest of the shape and just look at the green triangle. So I need the area of this triangle. Well, I need a height in order to be able to do that. So that's 3. So I need to use Pythagorean theorem to find that. Since I have 2 sides, I'm going to use Pythagorean theorem. So 10 squared minus 3 squared, take the square root of that, and you get 9.5. Okay, so then to find the area of the base, you would do half of 6 times 9.5. Now again, notice that the height of your triangle is different than the height of your shape. Okay, so please learn to isolate two-dimensional figures and then three-dimensional figures. Okay, so you can finish those out just by using the formulas. Now, I want to switch over and let's talk about cylinders. So cylinders are similar. In fact, the area or the formula for it's still perimeter, except this time it's called circumference. So the lateral area for a cylinder is CH or 2 pi RH. Now we like cylinders and we like cones because the bases don't change. They're always circles. Then your surface area, again, your lateral area is going to be your your can wrapper, right? Your green bean wrapper. That's going to be your lateral area. Your surface area is going to be that lateral area, that rectangle that's created when you open that all up. It's going to be that lateral area, and then you're going to add the top and the bottom, or the two circles, not necessarily the top and the bottom, but you're going to add two circles. And it's all area formula, okay? So to do lateral area, then it would be 2 times pi times r, which is 10, times the height, which is the distance between the two circles, which is 21. Now, again, just like always, we leave our answers exact. Some of you are still confusing exact and approximate. You think because it says 3.3 or whatever it is, that's exact. That's not. You just decided the rest of the numbers were not important. So multiply everything except the pi. 2 times 10 times 21. So 2 times 10 times 21, and you get 420. So my exact answer in terms of pi is 420 pi, because pi is holding all of those decimals in it. It's like containing them all. And so then if we explode it, we do 420 times pi. That's exploded. I'm going to use all those numbers. It's 1,319.468915, but I don't think the rest of those numbers are important enough, so I'm going to round it. Now, I know that makes it look exact, but it's not. There are actually numbers that exist in that math that I just chose not to write. Then my surface area, I'm going to take that 420 pi that I originally got, and I'm going to add 2 circles, pi r squared. So I'm going to take the 420 and I'm going to add 2 times 10 squared. So I'm going to take 420 and I'm going to add 200. That's going to give me 620 pi. Okay, and then if you type that all out, 620 times pi is 1,947.787445, but I just am going to round because they're not going to be exact. It's just approximate is good enough. Okay, and those are all inches squared. So 8 would be the same. The only difference is now, pay attention, look at how this is on its side. Okay, so this is on its side, but these are still my bases, and my bases are still circles. Okay, now be careful. The diameter is 15, but I need the radius, so the radius is 7.5. So my lateral area would be 2 times pi times r times h. Again, h is the distance between the two circles or the two bases, so that would be 32. See, if you do 2 times pi times 7.5 and then you do times 15 as your height, because that's how tall it's standing up off the ground, then you never left the circle. Okay, so you have to think about like you're pushing that circle back into like a jello or something, and it's going to leave a space. It's taking out a volume or a space, okay? So you got to think about creating what it takes to create that shape. So we do 2 times 7.5 times 32, and we get 480. So that would be 480 pi centimeters squared, or 480 times pi is 1,507.96, or that would be 1,508 centimeters squared, approximately. Surface area, take that same lateral area, 480 pi, and add 2 more circles to it. Okay, your right and your left, your bases. So 2 times 7.5, so 480 plus 2 times 7.5. And you get 495 pi is your exact. and then approximately would be multiply out by pi. You get 1,555.0888364. So I'm going to use 1,555.1 centimeters squared. Okay, so we've got exact and we've got approximate, so make sure you understand that. So a cylinder has a lateral area, it's a cylinder, has a lateral area of 70 and a height of 7. Find the length of the radius. All right, so as soon as you see lateral area, then you need to write lateral area for a cylinder is 2 pi RH. It's on your formula chart. Okay, so then start substituting in numbers, and then let's just see where we go from here. So my lateral area was 70 equals 2 and pi are your constants. We want to find R, and then we have H. So H is 7. So I like to do all the math that I can do. So I would do 70 is equal to 14 pi r. Now you could also do 14 times pi. Let me show you how you can handle this because I don't want you to make a mistake. You could do 14 pi and you would get 70 is equal to 43.9823 r. And then you would divide 70 by that. That's not right. You do 70 divided by 43.9823, and you would get that the radius is 1.6. Now let me show you the difference. It's actually 1.59. Let me show the difference. It may not make much difference because it's pretty small numbers. Okay, so that's my radius. Now, another way to do it is you could come over here, and instead of doing all of that work, what you could do, like what I mean by work is like typing it all in on your calculator, you could divide by 14 pi. Now, here's where I need you to be very careful because the 14 pi's, that all cancels out over there. But when you type this in your calculator, again, if you type in 70 divided by 14 pi, just like that, then you're going to get it wrong. 70 divided by 14 pi is going to be wrong. Okay, you have to divide by all of the 14 pi. So you have to type it in parentheses. So 17 divided by 14 pi. And it's pretty close. I mean, to the number of decimals that we carried out is good. So R is equal to 1.5915. So if I had rounded to say 44, I would have gotten a different answer when I did it this way, when I multiplied everything. Rounding always impacts your final answer. It is always best to keep your answers as exact as you can. So this is the best way to do it, by dividing by 14 pi, but as long as you write out the right number of decimals, or a good number of decimals, then you won't make such a rounding mistake, because both of those would have rounded to 1.6 and we would have been fine. Okay, so you need to know how to use these formulas. These and these right here, okay? The big thing, the one thing that I see all the time that throws people off is this height right here. That is the distance between the bases. That is so important because the height of the base is not going to be the distance between the bases. So you have to be able to separate finding the area of the triangle and then finding the area of the triangular prism or whatever shape.